Back to my channel. We're continuing Acing your technical coding interview. So the question we have, and we start the time, just 10 minutes. Maximum depth of a binary tree. So given the root of a binary tree, return its maximum depth. So a binary tree's maximum is the number of nodes along the longest path from the root node down to the farthest leaf node. Okay. So let's see an example. So the number of nodes. So we're counting the number of nodes. The longest path from the root to the farthest. So here, this is the root. This is the farthest leaf node, either this or this. So 1, 2, 3, or 1, 2, 3. So this is 2, this is 0, this is just 1. And the number of nodes in the tree could be up to this, and the value could be negative 100 to 100. Interesting question. So how do we solve this problem? We can, most times when we have tree graph problems, we want to first of all get all our base cases right. If we can get all the relevant base cases, then we are closer to getting the problem solved. So what we do is we look at the base case. When the root is null, so what do? We return 0. So if not root, so if the root does not exist, we return 0. Okay, and this that. Okay, what other base case can we have? If there is only one root, as in this case, if only root exists and there is no left and right, then we return 1. Okay, so we can handle that. So if not, at this stage, if the program gets to this stage, we know the root exists, so we won't get into a problem of null. If not root dot left, and we're sure there's not root dot right, what we do is we return 1. Now at this stage, we know that either we have left, or we have right, or we have both. So then what we need to do is to do recursion on that. So let's say we now have only left. So only left node, only left tree. So we have only left tree, so that means we will say if not root dot right. Okay, then what we'll be doing is we will be returning 1, because we already have one, we already have the root, plus then we need to recursively call this max depth on the left, so which will give us root dot left. So we use self here because it's a class, right? So this will recursively take care of everything on the left side. So we do similar thing for if only we have the right. So if not root dot left. So that means we have only uh, right tree. We return again the same thing because we have to add one because we already at least by when we get to this stage we at least have one node. So we recursively call max depth and you say root dot right. Now the last stage will be when we have both trees. So we have both trees. If we have both trees, what we'll do then is we want to return the max of either of the two. So we return 1 plus, because at this stage we already have at least one node, max of either of these two. So either this, whatever gives us the maximum, or this. Yeah. So this should do it. Recursion is very difficult to simulate and explain for us to do a walkthrough. But through a number of practices and handling the base cases correctly, then you can have a rough idea that what you're doing is correct. Okay? Because let's try the simple ones. If this is not, so this gives us 0. If we have only this, so there's no left, there's no right, so this gives us 1. So that's pretty good. Let's see this case. And to draw that case, 1 null. So let's see that we want to draw that case. So what that case will be, add a page, draw. Okay. So I'm trying to draw this. So what this will be is, okay, we have a root node which has a 1, the left is null, and this is 2. Okay, so this is the way this would be. So we don't have left in this case. So that situation will be, if not root dot right, we have right. So to not do that, if not root dot, so we don't have left. So what you do is that it will add 1 plus make a recursive call on the root dot right. So at that stage we're going to be here. So this is where we are now. So it takes these 2 as the new root. Then if not root, we have root. If not root dot left and root dot right, okay, we don't have left, we don't have right. So it returns 1 back here. And this eventually returns 2, which is what we expect. Okay? So that makes sense. As you go deeper, it will become much difficult to trace. It will become much difficult to trace because we now have a lot of recursion. So if you want to look at this one, for instance, let's see how far we can go. So we take the root, if not root, so that's not the case. If not left and right, that's not the case. If not right, that's not the case. If not left, that's not the case. So this is the case. So here at this point we already have 1. So we're counting this root 1. Then it goes to the left, which is this, becomes the new root. If not root, this is not the case. If not left and right, okay, this is the case. So this one becomes plus max. By the time this one comes, it returns 1 because there's no left, there's no right. So this becomes 1. Then it backtrack to the second one here, so right. So it comes to the right, so the new root becomes 20. Then it comes in here and it says this is not the case, this is not the case, okay, this is not the case, but it comes back to this case again. Now it becomes very difficult to trace because we now have again another 1 plus max of left and right, so it's becoming difficult for humans to visualize. But as you can see, it does make some sense. What we are written makes some sense. So let's run it and see what we have. Okay, so we're running that. That's good. So let's try another one. Let's try this as well. And let's try this as well. So let's run all of that. Good, so it passed all our test cases. Good, and let's submit that. Good. All right, thank you and see you in the next one.